Hello everyone, welcome to Chemazon-Complete Chemistry. So in this video we are going to solve question 43 of GATE 2022 chemistry paper. It is based on iron-sulfur clusters, which is a topic of bioinorganic chemistry. So the question is the number of equivalents of hydrogen sulfide gas released from the active site of Rubredoxin, 2-Iron-Ferredoxin and 4-Iron-Ferredoxin when treated with mineral acid respectively are. Okay, so these are the structures. So the first important part is, let us try to understand what is the question is, we have to find out the number of hydrogen equivalents of hydrogen sulfide or H2S released from the active sites of Rubredoxin, 2-Iron-Ferredoxin and 4-Iron-Ferredoxin. So first of all, we must know the structure of all these acids, structure of all these iron sulfur clusters. Okay, so which type of sulfur is going to be released? It is the labile sulfur. Okay, it is called as a labile sulfur. Labile sulfur, or it is called as acid labile sulfur. Acid labile sulfur, it is the sulfur that is in bridge. Okay, it is present as a bridge. Okay, bridge between the two iron atoms like this. Okay, and there is another sulfur which is from the amino acid cysteine. So there are two types of sulfurs here. One is, okay, this bridged sulfurs, they are what? They are labile sulfurs. Okay, what is the meaning of labile, that we'll understand in a moment. And the other sulfur that is attached, that is part of the amino acid, that is called as a non-labile sulfur. Okay, this sulfurs do not get released on reaction with acid. Non-labile sulfur. Okay, so when you add acid to this clusters, what will happen is this iron sulfur bond will break. Okay, and what is released is sulfide ion. S2 minus is what? Sulfide ion. And this sulfide ion will then react with 2H plus ions, and what will be released is H2S. Okay, so for one labile sulfur, one H2S is released. Okay, one hydrogen sulfide gas is released. H2S is hydrogen sulfide. Okay, so I hope you have understood what is the meaning of labile sulfur. Only the sulfur that is part of the bridge, that are labile sulfur. Other sulfurs which are part of the amino acid, they are what? They are non-labile sulfur from the amino acid residue. Okay, so now let us see one by one. Try to identify the labile sulfur in all the three structures. This first one, it is what? This is the structure of Rubredoxin. Okay, so here, is there any labile sulfur? No, here labile sulfur is not possible, because for labile sulfur you need at least 2 iron atoms. Okay, and in between that iron there is this labile sulfur. Okay, so here there are 0 labile sulfur, so it will be 0 H2S gas will be released. Okay, now let us see these structures. This first one is, the name of this is what? It is 2-Iron-Ferredoxin. Okay, 2-Iron-Ferredoxin. Okay, here what you can see, there are 2 iron atoms, and which are the labile sulfur? This is the labile sulfur, and this is the labile sulfur. This is not labile, this is non-labile, this is non-labile, this is non-labile. All the sulfurs that are part of the amino acid residue, they are non-labile. Okay, they will not be released. So here there are how many labile sulfurs? 1, 2. Okay, so in 2-Ferredoxin there are 2 labile sulfur. Then this is the structure of 4-Iron-Ferredoxin. 4-Iron-Ferredoxin. It is just like our simple cubic structure. Okay, or you can say cubane structure. Okay, here there are how many labile sulfur? Again, you have to identify the bridged sulfurs. How many bridged sulfurs are present? So this is 1 bridged sulfur, 2, 3 and 4. Okay, this is non-labile, this is non-labile attached to cysteine, that is from the cysteine. Non-labile, non-labile. Okay, so how many labile sulfurs? 1, 2, 3 and 4. Okay, 1, 2, 3 and 4. So 4 labile sulfurs here. Okay, so what is the correct answer? In Rubredoxin there is 0, 2 Iron-Ferredoxin it is 2 and 4 Iron-Ferredoxin it is 4. So now here they have asked labile sulfurs. In next time they can ask you the number of non-labile sulfurs. Okay, that is also important. So the ones that are coming from the amino acids, they are non-labile. So that also we can count. Okay, here there are how many non-labile? 1, 2, 3, 4. In Rubredoxin there are 4 non-labile sulfurs. NL means non-labile. Here there are how many? 1, 2, 3 and 4. Here also there are 4 non-labile sulfurs. Here 1, 2, 3, 4. Here also there are 4 non-labile sulfurs. Okay, so labile sulfurs 0, 2 and 4. So what is the correct answer? So the correct answer is 0, 2, 4. That is option B. Okay, so I hope you have understood how to identify labile and non-labile sulfurs. Thank you.